let's talk about why we're here tonight. So Lindsay Brewer is one of my colleagues at Equal Experts and one of my friends, and an engineer at heart. Lindsay has over 20 years experience of helping individuals, teams, and organizations improve their software delivery. For the past 7 years, he's been a consultant with Equal Experts, leading a range of engineering teams in the delivery of large-scale IT services. Problem domains for Lindsay have ranged from public sector organizations like the UK's tax and passport offices to global online retailers. Lindsay loves helping bridge the gaps between user and business needs, engineering disciplines, and service operation. Nick Sutliff is an operations manager. You might not be able to tell because of the vest that he's wearing right now, but he's just come from the actual floor. And he has a varied background across manufacturing, distribution, and project management roles. Before joining Wayfair, Nick led the manufacturing operation for a major British food manufacturer, driving world-class performance through application of lean methodology and employee management. He loves to break complex challenges and requirements into simple, real-world solutions, which can be easily communicated and understood by all. So welcome to both of you. And the topic tonight is something I've never heard of. It's cyber physical systems in software delivery. So for those of us who haven't worked with them, these are physical mechanisms deeply intertwined with controlling software. Human interaction raises the complexity and unpredictability even further, making these challenging to work with. So tonight we are going to hear about and learn what happened when Wayfair, a major European online retailer, installed a cyber physical system at their UK fulfillment center to process orders for delivery. We're going to hear about the challenges presented when the system reached peaks of over 10,000 orders a day, and which chaos control measures were taken to reduce the process failure rate from 17% to 1% in just 8 months. That was a lot of intro, lots of interesting words. It sounds mildly sinister, but I'm guessing it's not. So over to you, Lindsay.
Great, thank you for that lovely introduction, Erin. Hello, everyone from around the world. It's nice to be chatting to you this evening. I'm going to do a little bit more of an introduction to the session, and then I'll hand over to Nick to introduce himself a bit more and his role on the project, and a little bit more about Wayfair, and then I'll cover a bit more about what I was getting involved in. This session is an experience report of our things we've learned from the last year of working on a cyber physical system at Wayfair, and how we applied a variety of lean methods to bring order to what started out as being a fairly chaotic process and system, and was causing a failure rate that was unacceptable and was actually costing too much to manually work around. So this is a session where we all summarize the approach we took and what we can learn from it that we can apply to broader systems, so not just cyber physical systems, but IT systems on the whole. Hey, Nick, do you want to introduce yourself and talk a bit about how you're involved in this project?
Yep, thank you, Lindsay. My name's Nick Sutliff. I'm the Senior Operations Manager for UK Fulfilment for Wayfair. For those of you that don't know Wayfair, we are an online e-com business specialising in homewares, home goods of all descriptions. So everything from light bulbs to sheds to summer houses to three-piece suites, you name it, we sell it a zillion things, home as we call it. In terms of scale, we operate in US, Canada, UK, Ireland, Germany, Poland, Austria, but we have literally tens of thousands of suppliers globally feeding into the process. So we are, depends how you count it, but if you exclude Chinese domestic online retail, we're the third biggest online retailer in the world. Sixth if you count the Chinese sites. So my role in the project is we installed a sorter at our UK fulfillment centre here in Lutterworth, as such, it falls under my responsibility. So my responsibility basically is pick, pack and ship is the short version of it. So getting it out of our buildings and to the customers in an efficient and timely manner. And I'll hand you back to Lindsay.
Great, thanks, Nick. I joined the project back in April 2021, and at that point the sorter was installed, but there's still a lot of integration with systems to do, a lot of testing to do, and then a lot of optimization. So I was brought in as a technical program manager. I'm a consultant with Equal Experts, so I'm more used to working with what I'd say more straightforward IT systems that either have points of interaction that are web-based or through kind of other devices. This was my first experience of working with a system that had a significant physical component to it, which is what made this one of the most interesting projects I've worked in my life, apart from the work I did with URM, of course. So, okay, let's get on and talk about the problem domain. So give you a bit of a background about what we mean by cyber-physical systems and their relevance to Wayfair. What do we mean by a cyber-physical system? So when you think of the word cyber-physical, your probably mind, especially if you work in tech, jumps to these kind of cyber-physical. We're not talking about this kind of robot or cyborg. If you have a very long memory or you're into Doctor Who, if you're not from the UK and don't know what that is, worth Googling. We're not talking about these vast armies of sinister robots either. The cyber-physical systems we're talking about are much less threatening, much more innocuous, and they have a more mundane purpose. So they are systems such as Ocado's Hive, which you see in the top left here, which is a robotic system for picking people's groceries that they've ordered online, putting them into a bag that then go into a truck and to be delivered. Or over in the top right, which is a bread making factory where Nick used to work a while ago. Then the bottom left, it is that's what happens to your suitcase when you drop your suitcase off the airport, as imagined by various movies. And then bottom right, you see the sorter that we worked on at Wayfair. So all of these things have similar properties that make them classed as cyber-physical. The kind of characteristics that cyber-physical systems all share are threefold. Firstly, they have a significant number of physical mechanisms, and those physical mechanisms are very closely coupled with controlling software. So there's generally quite a variety of different types of mechanisms, such as kind of robotic arms, lifts, conveyor belts, things that move product around, things that interact with products, so maybe scales. And there's also a variety of types of software. So the software stack and the system stack that make up cyber-physical systems is much more diverse. It does include certain types of Internet of Things, where there are Internet of Things systems where you have a significant number of physical components linked with a number of software components. So imagine if you wanted to deploy a large-scale system for detecting certain types of wildlife and then causing a specific action when it detects that wildlife, such as sending an alert or closing a trap. That would also be classed as a cyber-physical system. The second characteristic that they all share is the production load. When I've worked with other systems, the more straightforward IT systems, when we think about production load, we're generally imagining web requests going through a system, or events going through a kind of event processing system, or data being processed. Whereas a cyber-physical system, it will often have all those things, but it also has real physical volume going through it that you can touch and you can smell and you can hear and you can see. So it might be, it has groceries that are being put into boxes, or it might have a dough that is being made into bread. Or as in this case, in the photo, it has boxes that are moving around a conveyor. And if things go wrong, all of that physical volume has to go somewhere and something has to happen to it. And that's where things can get very messy very quickly. The third component that is not present in all cyber-physical systems, but increases the complexity significantly if there is a significant amount of human interaction with the system. So if there are parts of the system where that perhaps the production volume is being introduced to the physical system, or labeled, or affected in some way that affects the performance and behavior of the physical system. The sorter that we had at Wayfair ticked all of these boxes. To give you a bit better an idea, if you've not seen a sorter, there's some video that we have in action when we were testing it. So that was somebody inducting it, and then to be more interesting, we attached a GoPro to it so we can see it riding the conveyor. In this case, it's a very lonely carton. That was it going through the scanner where all the barcodes are read, and then these are the divert lanes. So a carton would eventually be sent down one of those chutes to the right, or as it went then up to the left to go somewhere else, and then down onto a truck. So that video showed a single carton riding around a very, very big sorter. This sorter has capacity for many thousands of carton per hour. So if you can picture that box amongst 1,000 or so other boxes all at the same time, you can just picture the kind of potential chaos that we have. They'll cover how does the sorter work and what's the kind of architecture behind it. It's not just as simple as putting a box on, work out where it needs to go, and then divert it. There's actually a lot of things that have to happen way ahead of the box being put on the sorter for it to go to a successful destination. That was one of the reasons I got involved. Across Wayfair, there were probably around 10 different tech teams, plus at least 3 other third-party teams whose IT systems had to interact correctly in order for the sorter to be successful. The sorter volume starts off with products being received into the warehouse. We have cartons coming in. They have to be labeled so you can identify exactly where they are and where they're going to be stored. They're also weighed and scanned so we know exactly what volume those cartons take up, so we can work out how they're going to fit on the truck. And you can see already from the very first step of receiving a product in this flow, we're talking about 3 different kind of levels of systems: human, physical, and cyber. So what happens, for instance, if when someone receives a product, they put the wrong label on the wrong product? There's opportunity for kind of problems there. Or if there's a bug in your scanning system, or a bug in your dimensioning system. We now have a warehouse full of products. The next thing we need is for a customer to come along and order one of those products. So that happens through Wayfair's various websites. During the checkout process, the delivery kind of estimate is organized, and that is done whilst the customer is checking out, where they look at the customer's delivery address, the product location, its dimensions, and all of those factors are combined to work out which warehouse the product can come from, which warehouse has the product in stock and has capacity, then looking at which carriers can take it based on the things like the dimensions and the weight and the product type, looking at which trucks for those carriers have capacity so it can ship to the customer and arrive within 1 to 3 days. That's a bit more straightforward, unless something goes wrong, of course, with the truck assignment, which was one of the interesting problems we had. So having got a product in the warehouse, then it's purchased by a customer. The time comes for that carton to be picked in the warehouse so it can be sent off to the customer. And that involves, again, a human, a warehouse associate, being directed to where to pick the carton from. They need to scan a label to confirm the identification of the carton, print a shipping label, which they put on the carton, so the sorter knows about the carton, and the carrier themselves can know about the carton. Things get very complicated, as you can see by all the kind of different terms that are being used at this stage. This is probably the most critical part of the system, and we've not got it on the sorter yet, because this is where the order, the physical volume, and the destination and the carrier that's going to get it there all come together, and those 3 things are all joined up by one label, a shipping label, which is kind of the critical part of this system. That again is an opportunity for many problems of different natures, cyber, physical, and human. With the carton picked and labeled, The next step is to organize which truck is going to go on, and that's done by another person in the warehouse who looks at which trucks have come in, assigns them to the right part of the warehouse, so the sorter knows which part it needs to divert it to. If that's been done correctly, then in theory, if that carton is then put on the conveyor, put on the sorter will scan it, so it'll read all the labels, work out exactly which carton it is, exactly where it's going to go, and then divert it to the truck that's supposed to go to. Simple, right? Well, okay, that's what the rest of this talk is about. Okay, over to you, Nick, to talk a bit more about how this fits into Wayfair.
Thank you. I'm glad you did the simple version of the architecture. Yeah, so I guess all of this needs to be viewed in the context of the Wayfair Way and the way that we operate as a business. So we have a very simple mission, or the ops mantra as it's known, and that is cost efficient, perfect orders at scale. You know, so as an e-commerce retailer, nice and simple mission. You know, the mission guides us in what we must do and what we must not. You know, so if it doesn't support cost efficient, perfect orders at scale, we don't do it. It's as simple as that. But what do the three phrases mean, I think, is probably the key bit. So perfect orders basically means what you wanted, when you wanted it, how you wanted it. Yeah, so on time, in full, in perfect condition, or right product, right price, right here, right now. You know, any of those phrases can be substituted really. Cost efficient for us means spend every penny that you have to and none that you don't. Okay, so we will not sacrifice the customer on the basis of cost. Okay, so it is about delivering perfect orders and then becoming cost efficient at that. And at scale means that the processes must be repeatable, they must be sustainable. We have to be able to do it thousands of times a day, and so it just happens in the same way every time. You know, any process, any small exception within a process multiplies very quickly and immediately destroys any cost efficiency. So you could kind of look at our mission as reducing waste, inefficiency and unevenness to provide value for the customer. It's almost a definition of what lean is about. If you want to just click it on, Lindsay. So if the mission is what we're about, our people principles guide how we go about it. I mean, to be clear, the people principles never say don't do that project, but they do inform how you should do it. So we are always improving, speaks of continuously seeking opportunities to grow performance, to grow as individuals, and to grow the business and to grow the team. We drive results is about using good judgment to deliver results, you know, and bring relentless customer focus to bear on what we're doing. And then we win together. It's about building the best team, collaborating effectively, harnessing everyone's ideas and skills for everyone's benefit. So that's our mission, and then how we go about achieving it. If you want to just click on, please, Lindsay. Or next slide, please, as people in the UK will have heard repeatedly for the last couple of years. So with the sorter, and a characteristic of cyber physical systems is that you pull a lot of data. You know, you have to translate that data though into something meaningful to make it information. Yeah, and I'm sure we've all seen comprehensive KPI sets where nobody's actually sure what the numbers mean or what the levers and drivers of the metrics actually are. So to keep it meaningful, we focus on a number that have a physical reality for the teams doing the work. You know, so it's not about what the numbers that the accountants want to look at, or even what I want to look at. It's what numbers are meaningful for the guys on the floor, for the women on the floor who are operating that sorter. But the metrics all add up to one simple target. If you want to click it on, Lindsay, which is get the box on the truck. Yeah, so all of our metrics that we focused on are aimed at one simple task. It's about getting the box on the truck so it gets to the customer on time and in perfect condition. So the four kind of key measures that we focused on for the sorter. The first one is what's called no read. And that's what percentage of cartons failed to be scanned by the sorter. A whole host of different reasons, which Lindsay will go into more detail on later as to why these things happen, but that's the first one. So it's a no read. We don't know what the carton is. The second one is recirculation. So what percentage of cartons could not be diverted successfully to a truck So they just go round and round the loop on the sorter. The third one is jackpot. So what percentage of cartons the sorter couldn't divert to a truck and so sent to a jackpot or a hospital lane, as they're called other places, to get fixed. And then utilisation. How much of the potential capacity of the sorter are we using? Are we actually processing enough and processing fast enough to fill the trucks before their cut times? Because for no read and jackpot and recirculation, an easy answer to make that better is slow the sorter down. But if that results in the customer doesn't get their order, well, that's not helped. So you do have to balance the scorecard across all four measures. So the first 3 months really were about a transition from human decision making and action to automated cyber decision making and action. For example, a human knows that a parcel can go on any truck for carrier B. A cyber system has to be taught that logic. So it seems really simple, but actually it gets very complicated very quickly when you've got multiple carriers running to multiple destinations with multiple possibilities. So what we chose to do to learn those lessons is we started with the single smallest carrier. So out of this site, I used 9 different carriers going to 19 different destinations every day. We started with the smallest to prove the technology, so the least pain approach. Then, once we got the smallest carrier working, we added the largest because we needed to prove that it would work at volume. Then we added one destination at a time until all were capable of being sorted. But as you start to increase that volume and differing use cases start to come on stream, the level of chaos increases exponentially. And I should point out that I use the word chaos here in a very specific way. It's not just a random statement. You can classify the maturity of the operation into distinct phases, and the bottom level of that is chaos. So chaos describes an operation where there are unexpected or unknown issues with no defined responses and no rules how to deal with it. There is no playbook. You are literally making it up as you go along. We had some advice from US sites who were already operating sorters, but their tech stack is different to what we have in the EU. Also, this was in the middle of COVID, so there was no cavalry coming flying over the Atlantic to help us with this installation. Once you get through chaos, you start to get into reactive. You know what some of the problems are, and you have some planned mitigation to deal with them. So that's your firefighting stage. After that comes control, where you understand what the issues might be. You have planned responses to them. You have contingency in place to minimize it. It's also called the calm phase. And then there are 2 further phases of starting to be an innovator, starting to improve the system, improve your responses. Once you get past that, you then start to consider yourself perhaps as being truly world-class in your approach to what you're dealing. But the first 3 months was all about chaos and learning what we were doing. And if you want to click it on, I think at that point I'll hand back to Lindsay.
Thanks, Nick.
Thank you.
Right, let's talk about what happened and what was the chaos that we saw. We'll start off by just covering how different failures can happen in cyber physical systems. So I've divided the system into basically 4 layers. So at the top we have humans, and humans are fallible. So all the time we're trying to minimize what humans are having to do in these systems and minimize the opportunity for mistakes. The simple mistakes that can then ripple down and have impacts later on is when someone picks an order and they print out the shipping label, and maybe they see 2 boxes that are both the same type of carton, and they put the label on one of the boxes that turns out to be the wrong carton. That can then be picked up later on in the system and cause the carton to be sent to the jackpot lane, because the system would have realized that it's not the right product that was ordered. We use the term jackpot throughout this presentation, by the way, and just wants to stress that it's an industry standard term that doesn't mean what you think it means. So jackpot is generally a bad thing. You don't want jackpot at all, minimum jackpot. There are some places called a hospital lane, which is perhaps a bit more appropriate, but we were focused on the jackpot metric. Then the second layer down is the actual product. So, and this ranges from the actual physical thing that you're trying to ship or move around, such as a carton. It can also be some kind of mechanism for transporting it. So, for instance, we had very small cartons or kind of envelopes that, in order to ride the sorter, they had to go into black plastic trays, because otherwise they were below the minimum height and they would kind of interfere with different parts of the sorter mechanism. Those trays then present a kind of a physical product that can also cause problems. We used what we call tacos, which is a great term for holding rugs or other cylindrical items. Because imagine if you're putting a cylindrical item on a flat surface that's moving it very, very fast, like through different kind of directions, pretty soon it's going to start rolling around and causing problems. So if you picture a taco from Taco Bell or wherever you get your tacos from, this is what we effectively designed and made, was a V-shaped long kind of carton that had a flat bottom that you could place a rug of varying sizes in, and it would hold it snugly, hold it tight, and it means it wouldn't roll when it went around the sorter. They cause a whole another class of problems by themselves. Then we get down to the physical mechanisms that make up the system. So this can be things like the rollers themselves, or the things that push the cartons around. So the what we call the shoe sorters. There's also the sensors, the photo eyes that the cartons go past, and they trip a light beam and get detected in that kind of way. The scanner itself has physical cameras that are taking, in this case, digital photos of the carton as they passed, and that simple physical mechanism it has a focus length, so it's got a range, an optimized kind of range of kind of focus. So if you get that wrong, that can cause problems as well in terms of labels not being able to read correctly. We finally now get down to the cyber system. If you've worked with any kind of IT system, you can imagine all the different problems just one IT system can have. Now times that by probably about 10, because there's software that's made by one vendor for image processing. There's another software that's made by the kind of system that detects the events that are going around the sorter. Then another system that has to process those events and decide kind of how to respond. Then we have the myriad of Wayfair systems that are doing truck assignment, label generation, label printing, reassignment. All these things can go wrong, just like IT systems do go wrong, that can then impact the sorter. So hopefully you can see from these different layers how kind of cyber-physical systems quickly become very, very, very complicated. So let's dig into this in a bit more kind of detail. Why is it so hard when you have these kind of failures? I was trying to think of an easy analogy to this, and I was reminded of when I was doing biology at school, and you're looking at things like soil samples and ecosystems. And it's hard to kind of, when you look at the kind of this photo, it seems to have clear layers, right? And you think, well, okay, if the grass is dying at the top, then perhaps there's too much sunlight, or there's something that's been put on top of it that's causing a problem, so we need to look at that layer. But what if the grass is dying because there's a problem right at the beginning? And when you start kind of looking at like ecosystems and realizing that the behavior at one level is significantly influenced by another, that's what you have with cyber physical systems, that each layer can be very, very different, but because these layers are all connected, so it can be very hard to diagnose kind of the root cause and then work out how to fix it. When we apply this to cyber physical systems, and particularly sorters, we observed kind of various problems throughout the integration, testing, and optimization. And each time we were looking at a problem, it wasn't obvious, wasn't clear which layer was it. Was it just the layer by itself? Was it one layer interacting with another? Such as when a human is like scanning a label and putting the label on the box, or maybe when the conveyor belt is moving a carton around and diverting it in a certain type of way. So it meant we had to learn, how do you study each of these systems by themselves and their interactions with each other in order to work out what could be possibly going wrong. if we come up with a specific example, so Nick talked about no reads being a key metric. And just to recap, this is when the sorter knows there is a carton going through the scanner because it's tripped the light beam, but it couldn't read the label. And if you can picture that on the left-hand side, we have various types of labels. Do they look okay? Are there problems with them? Well, there could be problems with them. It's hard to tell at this stage, but imagine you are a fortunate associate that is working on the jackpot lane at the sorter. So again, jackpot lane is not a good place to be. You don't want to be on the jackpot lane because that's where all the problems come. And sorter starts up, and within an hour, you have so many boxes you don't know where to put them, which is what we see in the larger photo. And so you start processing these boxes, thinking, okay, well, how do we sort these out? We've got to ensure that the customers' orders aren't late, and so we need to invest, time, physical time, rather than having an automated system sort them out. So we need to work out how can we understand why these things are coming here. And it's not obvious when just looking at one of these labels what the problem is, because of this kind of a tree. So this, and I've simplified this tree just to show. Make it a bit more easy to read. So it could be that the no read happened because the barcode was hidden. So perhaps it was a small item that was put in a tray, and because the tray is not see-through, the barcode is not on the top of the carton, it doesn't get read. So again, that's a kind of a physical problem. If people don't know or remember to ensure the label is facing up on a tray, you get this problem. What if they forgot to apply the label? Same kind of problem. Then we get on to another class of issues. So the barcode is definitely there. It's definitely visible, or at least visible to a human. Why didn't it get read? Well, it could be that when the label was detected and the image was processed, there was some distortion due to the image processing algorithm. Or perhaps it was a height issue. So perhaps when we configured the cameras for their focal range, perhaps we didn't make that focal range large enough. And we certainly found that with some very thin cartons. We realized that the focal range wasn't quite kind of big enough to pick them out. But the focal range, again, is that because of how we configured it, or is it because of trays? Because if you have something in a tray, then a tray has edges. And what we found is that if an item is very, very thin, much thinner than the height of the tray, then the camera doesn't know whether to focus on the top of the tray or the carton that's inside the tray. So you get the idea. It's trying to work out exactly what caused each of these defects, essentially, takes quite a lot of investigation. I could talk to you about this all night, but I know we're kind of pressed for time, so let's go on. So why does a carton jackpot? So what are the other types of things that could happen? The process for getting a carton successfully to its destination is very, very simple. It needs to be detected by the sorter. The sorter needs to read the barcodes, work out what type of barcodes each barcode is, and then look up those barcodes in its database of barcodes for all the cartons that it's been told about. Then look up where is that unique carton supposed to be going in terms of which kind of part of the sorter, and then divert it. Yeah, simple, right? So what could possibly go wrong? Well, we've broken these problems down into these kind of terms that we then could get kind of data on and measure. So Nick's described about no reads. Then the other four are different types of jackpot. So if a carton can be scanned, but the barcode is not found in the database the sorter has of all the cartons, then we say the carton's not been found. What if the carton is found, but is actually found twice because there's multiple barcodes on a carton, and if a person puts a label on the wrong carton, then that carton can be matched to by two different barcodes. And so we say that's a carton identity mismatch. Again, we don't want to send the wrong carton to the wrong customer, so it goes to the lucky jackpot place. It could be that the carton is found, it's got one barcode, it's unique, but when the sorter looks up where should it send it, it doesn't find a configured destination for that carton. So again, it can't divert it, it doesn't know where to send it, so back to jackpot. Then finally, those kind of lanes, the parts of the sorter that send cartons down to the truck, they have finite capacity. and people are only so quick at taking cartons off the end and putting them on the truck. So it's possible, and if things go wrong with the sorter, it's possible even more that lane kind of backs up, and so you can't physically divert any more cartons down that lane. And if that happens, we do what's called recirculation, where we just, instead of sending the carton down the lane, we send it back around the sorter, and it tries again to divert, keeps going around. You don't want cartons recirculating forever, so you have to have a limit. And once that limit gets reached, we send it to jackpot. So that's a kind of brief guide of the different kinds of problems that we had to tackle. And this is a pie chart from when we, probably about a month or two after we went live with the sorter, and shows the kind of the breakdown. So now this looks fairly simple, do you think? Because there's some clear big problems that we need to solve. I've just talked you through why each of those problems happen. So really simple problem to solve, I think. Well, two things that made it really difficult is that pie chart on a daily basis physically looks like this. And when you're faced with hundreds, sometimes 1,000 cartons that are at jackpot, and you're trying to figure out what to do them and why they actually came there, it's not possible to look at every one. Sometimes it could take half an hour to understand why one carton came to jackpot. So the sheer volume was quite a problem. The other significant problem is shown by this graph, when we were looking at how does the different failure types vary on a daily basis, which is what the bar charts are, and does that have any relation to volume, which we saw it did. The squiggly line is the kind of actual kind of numbers of cartons that are jackpotting. What this was kind of is summarizing is that it varies a lot on a daily basis. Each day there's not like a clear problem that is consistent from one day to the next. I think this is very symptomatic of cyber-physical systems, that because humans and physical things can interact in so many different ways, so those different interactions can cause significant different kind of types of problems on a daily basis. So for instance, what if you forget to assign a truck to the door, so the sorter doesn't know about it? So if that happens, then that would cause what, 40, 50, 100 cartons to go to the wrong place, to go to jackpot. So just that one simple action can cause a kind of a problem very quickly and skew these results. So what did we do? How did we get control of this chaos? Right, I'll hand you over to Nick to continue this.
Thank you, Lindsay. So the first step that we took is splitting it down into 3 buckets, which Lindsay has kind of already spoken about, really. So plant, products and people. So of the problems that we're looking at, which problems relate to the people? So the top left picture there, that's the Blue Crew sorter team celebrating the sorter being running for a year. We had a little birthday party for it. What problems are associated to the product itself and the ancillary equipment that we use, so tacos and totes and trays. And then finally, what is just down to the plant. And when I was working on it with my team, plant meant both the physical plant and the cyber world. Because for us, that's just the kit that's standing there in front of us. And to be fair to the sorter team that are working on it, they can't tell whether it's a mechanical issue with the piece of kit or whether it's the controlling software that is causing the issue. So we split it into 3 kind of mega buckets in a way. If you just want to click on, hand back to Lindsay.
So that was one way of kind of slicing it, as Nick described. One of the other things that we had to take when we were looking at the different types of problems was how do we prioritize which of these classes of problems do we go after? Because it was a significant problem for us when we went live. So senior stakeholders were very keen that we put a lot of effort into kind of resolving it. And so we couldn't, because of the diversity of the problems, we couldn't just like pick any of them. It made sense to pick something that was having the most impact. So we came up with quite a good kind of formula of basically that used data, and the data that we're using were firstly what percentage, so average percentage across a month of cartons are being impacted by this jackpot. And that's what the percentage column is that you see in the third column on this table. Because although this kind of varied on a daily basis, if we were to average it over a month, that would tell us, what have we seen the last month? It means the next month may kind of be very similar. So then the next kind of factor was, we know that each carton, if there's a risk of it being late, then that will make our customers sad, and that may mean that then they may decide not to kind of buy again with Wayfair, or we might need to give them a refund, or the carton might get damaged. So all of these factors then give you a kind of a dollar figure, which you can tie to the likelihood of something being kind of delayed or going to jackpot. So we were very keen that to reduce the manual cost of avoiding this impact. So the process of basically having humans sort out all of these jackpots and ensure they got on the right truck at the right time. We came up with this matrix, used the data that we're getting from the sorter on the different types of problems, to then basically attribute a kind of a rough kind of cost impact to the particular problems. There are some problems that we didn't know kind of what the root cause was, so we would just group that together and decide if it's having enough impact still, then we need to invest a lot of time into further diagnosing it, and we'd keep doing that diagnosis until we got down to a clear root cause and an owner for that. And as the owner column shows, sometimes it was the same tech team that was having to resolve it, or the same third-party supplier, or something to do with the operations team. That also impacted prioritization, because we couldn't ask like the same owner to tackle 5 different problems at the same time. They needed some kind of prioritization, and this kind of approach to using data was really helpful kind of to deal with that. The other principle that we used, having kind of broken down different impacts and work out who the particular owners are, was to focus on just one thing, because if we can fix one thing, then that's one less thing to like cause confusion, one less thing that's going to cause problems going to jackpot. So sometimes when we found something that was having low impact but we know was really easy to fix, then we just went after that because it was a way of kind of whittling down. Sometimes when there are things with a much bigger impact, they do take a lot longer to understand and to kind of to fix. And so we had to come up with kind of more detailed plans for that. The next thing that we did to try and kind of address the chaos was looking at how do we respond during incidents. Over my years working with software, I've been very interested and a lot of work on improving responses to live issues and learning using postmortems to review what happened in a production issue and what we can learn from that. And I'm used to doing that with software teams, but I'm not used to doing that with teams that span the cyber-physical domain. So this is something that we had to learn, was what happens when you do suddenly have hundreds of cartons come to jackpot. That's a production issue. And it's no different from when your website is down, apart from it's probably a little bit more stressful because you've got these things piling up. So we had to learn, how do we apply the same kind of live issue management and then postmortem kind of management and learning process to a cyber-physical system, made slightly more difficult by the fact that across the different layers, we had people distributed around the globe, as you see here. The fact that we then were having to try and resolve some of these issues over video calls introduced another kind of cyber-physical layer on top of that, just to add to the complexity. The next thing we did was to get a really much better understanding and learn how to use all the different observability tools to understand what was happening at each one of those layers in the system. So if you're kind of worked a lot in tech, some of these things like Grafana in the bottom left or Kibana in the bottom right will be familiar to you. I had to learn a lot more systems, and Nick and I have lots of fun getting to grips with things like what you see in the middle, which is the user interface for the sorter itself. Then further up, you have the cameras to see what is actually happening on the sorter. Where are the cartons kind of going? So when we were diagnosing no reads, for instance, sometimes we had to start with use the camera, the scanner photos, and the kind of dashboard in the middle, and try and work out which of these cartons was the no read, because a no read isn't identified. We don't know which carton it was. It was lots of fun. Things that I can learn from this was that you need to apply the same kind of observability principles you do in software to the whole stack. So make sure you have observability over the whole of the kind of cyber-physical interactions. And that observability can go far back enough in time that you can diagnose something that happened, a week ago, 2 weeks ago. It's really important as well to be able to trace a carton or like a product, an event, all the way through. So how was this item received? Where did it go in the warehouse? Who picked it? When was it inducted? And what happened to it? This can be particularly difficult if part of your system that identifies a product has a problem, like we had with no reads. Make those observability systems easy for everyone to use and to be able to share the results of. So when you're having a live issue, it's really important to be able to easily share graphs and images that are helping you diagnose something. And then most importantly, be very respectful of kind of laws and people's privacy. If you have cameras that are placed around where people are working, sometimes that's not fair on people, or people are uncomfortable with that, or it's something that is against the law in some places like Germany. So there's many concerns that need to be kind of borne in mind when you're looking at physical system observability. Right, over to you, Nick, to talk a bit more about the operations side.
Yeah, thank you. And all of this techie stuff is great, and apologies to all the IT people on the call. Yeah, it would be lovely to say that we could have an A plus B equals C at all times, even if it's hard to find that and to understand it. But unfortunately, we've got carbon-based, squishy living things involved, and people don't quite respond to commands and logic like a computer does. They always ask why. That means that you have to tell them, fundamentally, and it means that you need them to be engaged in what you're trying to achieve. And the first step to engagement is getting people to understand what good looks like. So this is a genuine example that it's part of the training that we give to our associates, and these are displayed at the workstations in all areas. What it says perhaps isn't that important, but the aim of the different boxes are. So we start with the purpose. So what's the purpose of the role? Why are you and what you are doing important, ultimately? Then we talk about safety. I want my people to go home in the same condition that they came to work in. So how do you stay safe whilst you're doing it? Then perfect orders. So the heart of our mission at Wayfair. So how do you, carrying out this role, add value for the customer? And then cost efficient. How do you add value for the shareholder? And all of our employees are shareholders. So when we talk about shareholders, we mean all of us as well. If you just click on, please, Lindsay. In addition to that, there's some simple kind of philosophies and approaches that we apply to it. The first one is It's Your Ship. It's a book by a guy called Michael Abrashov. I strongly recommend you go out and get yourself a copy and read it. But basically, all it tells you is that you need to give the authority and autonomy to your people, from associates, team members, colleagues, whatever you call them, through your frontline management, that they own the process. It's their ship. Nobody will know how to do the job better than they do, because they're the ones closest to it. So but also it's your ship. It will be as good or as bad as you personally want it to be. So you have the power to make it better for yourself and therefore for the business as well. If you want to click on. The second philosophy that we took with the guys is, will it make the boat go faster? Again, it's a book by a guy called Ben Hutton Davis. He's an Olympic rower. Get the book, read it, but there's two key points. Firstly, it says, if it will help us achieve what we want to do, we should do it. And don't worry if it's the biggest bang for your bucks, etc. Just, will it help? Will it make the boat go faster? And if the answer is yes, do it. Secondly, if it isn't aligned to our aim, it won't make the boat go faster or improve jackpot, for example, don't do it. It might be cool, it might be a brilliant idea, but it adds nothing to what we're trying to do. So we have to stay focused on the goal. If you want to click on. And then the third philosophy that we put in is a quote from Mario Andretti, and that is, if you feel totally in control, you're not going fast enough. Basically, it's easy to relax when you get to a state of control, but you won't win races. So if you feel totally in control, you're not going fast enough. If you want to be lean, you'll often be teetering on that edge of chaos. And you have to accept that sometimes improvements won't work. and you'll actually go backwards. Sometimes you win, and sometimes you end up in the gravel. But you'll never win if you drive so that you can never end up in the gravel. So you have to accept that with the ownership that you've given to your team, with it's your shit, sometimes they'll try things, and sometimes it will work, and sometimes it won't. But sometimes you've got to take the hit to learn something new, and that new thing leads to the next idea, and that's the one that moves the operation forward. If you just want to click on one more, and then the last one is back to our people principles. We win together. So recognize the successes, say thank you, say well done, set goals and reward achievement. This might be pizza for the team or a birthday cake after a year of running. This is the yellow team. I showed you the blue team earlier. This is the yellow sort of crew. Your senior leadership have to be visible. They have to be personable, to be present and understand the reality of the working lives of the people at the coalface. You have no credibility and make the wrong calls if you're not. So it is about us all working together. So the net effect. So this is from the beginning of this year through to August. As you can see, from January through to July, using the approaches that just described and all the detailed kind of tech diagnosis and perhaps more traditional analysis that Lindsay's described, we reduced jackpot and recirculation by around 80% over that 8-month period. What you will notice at the right-hand side of the graph is it spikes back up in July and then starts coming down again. That's the Mario Andretti effect. We took a chance. We reduced the running hours of the sorter, we increased the throughput, we put more pressure on ourselves, and it hurt for a bit until we get the performance back where we need it. But if you feel totally in control, you're not going fast enough. That's how we continuously improve. So with that, I will hand you back to Lindsay.
Great, thanks, Nick. So I'm going to summarize some of the key takeaways from the session, from our experience working with cyber physical systems. I wish I'd learned earlier on that to make a cyber physical system successful, you need to look at much broader cross-functional teams. In traditional software teams, we've learned over the last 10, 20 years that cross-functional agile teams are really, really effective. They're having developers, QAs, designers, user researchers, DevOps engineers, all in one team. It's great. With cyber physical systems, you need to look much broader than just traditional IT roles, and look at operational roles, look at people that repair with spanners, the sorter, or people that work with the control systems. Think much more broadly about the different people that are involved in your customer journey, and that maybe you should include in your team in some way. Secondly, when you're faced with a kind of a myriad of problems, get some data together that can help you kind of try and understand the impact of all those problems, and then use that data to try and whittle away at each of those problems. We found that in order to kind of sort out this problem, we also had to apply observability across the stack. So making sure that whatever system you're working on, you can see how product production volume moves through your system at every level, and be able to connect each of those stages together. So trace any kind of production request or carton or product through the whole system, and so you can diagnose when it does have a problem what caused it. Also think more about your incident management and your post-mortem. So are there other people outside of your IT team that you should be including or training in how to respond to production issues, and how to evolve in post-mortem, so how we can learn when things go wrong. So that's covered 4 different kind of key takeaways that I encourage you to consider how they apply to the systems that you work with. That is the end of our talk. So I think we have like 2 minutes for any questions.
There's one question that might be a good one to be possibly the only one. That's all the time we have. Is there anything either of you would have done differently the next time you did a project like this?
Yeah, I think there's lots of learnings to take away from it. Probably don't try and do it in the middle of a global pandemic is the good one. Just because there was a lot of skills within the business and elsewhere that we just couldn't draw on in the same way. I think Lindsay's first key takeaway of we were probably slow getting a big enough cross-functional team together. You know, had we had that in place earlier, I think the first 3 months would have been significantly less painful than they were.
I think from my perspective, I think it'd be getting an understanding of the system to the point where you can trace a product through, and you can understand, you know, what are all the things that impact how a product, you know, moves from that whole journey that I showed you, and you know, work out all the different observability tooling and the identifiers that they allow you to trace it. Because it took me several months to do that, and once I'd done it, it seemed so simple. And I wish I'd had that knowledge, you know, several months ago. But yeah, it's perhaps a hindsight thing. But I think the next system I work on similar, I would try and do a diagram like the one I showed in the talk, and understand the different observability that helps with that.
I love that you've given us all permission to be slightly out of control in our jobs. That's a very satisfying message to hear.
Yeah, if you're not teetering on that brink of chaos, then are you actually pushing it as hard as you can do to achieve success? You know, and somebody else once said to me, if you aim for the stars, sometimes you'll hit the ceiling, but if you aim for the ceiling, I guarantee you'll stay on the floor. So.
Well, hopefully that gets you a lot of new candidates applying to Wayfair. So I just want to thank everyone for questions, and anyone who participated tonight, and especially Lindsay and Nick for sharing your experiences and your insights. I'm still thinking about the bread cipher system. Anyway, so we have another expert talk online on Wednesday, the 21st of September, again at 6 p.m. BST, and the speaker is going to be Chris Rudder. He's a security principal at Equal Experts, and he'll be telling you how to make DevSecOps a thing of the past. If you're interested in learning more about working with Equal Experts and joining the network, go to www.equalexperts.com/join-EE. Thank you, everybody, for joining tonight, and we'll see you at the next one.